is where we're starting. And this is absolute value inequalities. The nice thing about today is it is going to look similar to what we did yesterday, except for yesterday was equations, right? So there were equal signs. Today you're going to have less than, greater than, less than or equal to, greater than or equal to. And you do have to take it one step further with that. It's not just make it positive and make it negative. You have to do something with your symbol as well. So I'm going to start just by telling you about a little trick that you can use. And then we'll actually work through problems and show you how to do it. If your inequality is less than, okay, as long as your variable is on the left side, how we typically like to see it, okay, if your variable is on the left and it's less than, here's how we help you remember. We say it's less than. Okay, that's an and problem. Remember we talked about the and problems and the or problems? How do you graph an and problem? This way, right? They're coming together. Okay, so if it's less than, like this, or less than or equal to, you are doing the and setup. Okay, less than. If it's greater than or equal to, we say it's greater. Okay, so if you have this symbol or this symbol with the variable on the left, okay, so as long as your variable is over here, if it's greater or greater than or equal to, it's greater, that is an or problem. Okay, so less than, greater, might help you just remember how you graph it and how it should get you your final result. When you are doing absolute value, instead of just saying the equation, once you've isolated, right? Once we've isolated, you don't say the variable or the expression, whatever you have left in your absolute value, equals the positive and negative. You're going to do a positive and negative, but the first one, you're going to leave your symbol the same. And the second one, where you make it negative, you're going to flip your symbol. Okay, which you have some experience with flipping the symbol, so that hopefully will be good to us. But let me just show you a few examples, and I think you'll get the idea from that. So this is like example 4 in the book. If I give you the absolute value of 8n is greater than or equal to 24, okay? You have to isolate. Have we isolated? It's isolated for us, right? We didn't have to do anything. It's just absolute value on the left, okay? And our variable is on the left. So our symbol will tell us if it's an and or an or problem. Which is this going to be? Greater. It's greater than or equal to, right? So we say greater. So that's helpful just in determining once you solve it, did we do it the right way? What you need to do with this is you need to write it 2 ways now. So 8n is greater than or equal to 24. And then your other inequality, anyone based on what I told you, think you can tell me what the other inequality should look like? Not greater than or equal to. You got to flip it now, okay? So you're going to flip the symbol, less than or equal to, and then make it negative. Okay, so 2 things, flip and make it negative. Because we're talking about distance from 0, right? It's basically you're saying, so one ends up over here, greater than or equal to. The other one has to be, based on the relationship between them, the other one has to be on the other side, not necessarily of 0, but of some number of distance away from something. So it flips the symbol and makes it negative to show that gap, I guess you would say. You'll see as we graph it how it lays out. So you have this set up. We're going to solve it. Okay, we're going to divide by 8 here. So n is going to be greater than or equal to 3. okay? And we said it's greater, so this is an or problem. Over here, you're going to divide by 8, so n is going to be less than or equal to -3, okay? So if this is our setup, when we go to graph it, you have a 3 and a -3. Are these going to be open or closed dots? Why? Because it has the equal to underneath it, right? So that's closed. So you're going to do a closed dot here, closed dot here. So n is greater than 3. That's going to be this guy over here, greater than 3. Okay, less than or equal to -3. You're going to the left on that because it has to be less than -3. So that would be the graph of it. Okay. If we didn't flip it, you'd have overlap of, it wouldn't be an or problem anymore. You'd have overlap, like your 3 would go, your -3 would go this way instead, which wouldn't make sense. If we picked a number here, like -1, if we plugged in a -1 to that original equation, that doesn't work, okay? But when we flip it, our numbers work out with that. So, how about this one? If I give you the absolute value of 2x plus 4 is greater than or equal to 5. Okay, so first thing you always have to do is isolate. Do we need to do something to isolate right now? No, it's isolated already, right? So what you're going to do is you're going to rewrite it. Nathan, can you tell me one of the ways you would write this? What's one of your inequalities that you would write? No? How about Amanda, can you tell me one way you would write it?
What are you talking about?
To write your inequality 2 ways.
Oh. You're talking about the less than greater than?
Yeah, you'll use less than or greater than, well, less than or equal to, greater than or equal to. But you need to write your inequality 2 different ways right now, right?
Oh, okay. I don't know how to, because I know the way that you did it last time in the other example.
Same thing.
It is?
Mm-hmm. So one of them you write it, okay, here's the deal, guys. The first one, you write it exactly like you see it, right? The only difference is you're going to take away the absolute value right now. So your first one is going to be 2x plus 4 is greater than or equal to 5. Do you want to try and give me the second one? Did you know? No? Who thinks they can give me the second one?
Is it 2x plus 4 and then same sign?
Different sign, right? You got to flip your sign, so less than or equal to.
Then is it like 8?
No, you just change your number from a positive to the negative,
Oh, okay.
okay? So this would be -5. So you have your 2 inequalities, and now you solve. So if I solve this one, we're going to take away 4. So I get 2x is greater than or equal to 1, and then I divide by 2. So x is greater than or equal to 1/2. Okay, or you could call it 0.5. Quick question. Is this an and or an or problem? Or. It's greater with our variable on the left, right? So this is an or problem. What do I do on the second one? First step is subtract 4 again. So you get 2x is less than or equal to -9. Divide by 2. Do I flip my symbol when I divide by 2? No, because you're dividing by a positive, right? So x is less than or equal to -9/2. I don't care if you write this as x is greater than or equal to 0.5 or x is less than or equal to -4.5. Either one of those is fine. Leave it as the fraction, leave it as the decimal, whatever makes more sense to you, I will take. Okay, so when we go to graph it, if this is 0, 1, 2, oh, just kidding, this is negative. Let's call this 0. So -1, -2, -3, -4, -5. 1, 2, and 3, right? So 0.5, you're going to plot. That's 1/2 right here. -4.5, you're going to plot. What direction am I going with my arrows? In or out? Out, right? Remember or problems, like oars on a boat? Oars go out of the boat, right? Or goes out. So you would draw your arrows this way. X is greater than 0.5. That's going this way. X is less than -4.5, going to the left. Okay? Questions on that? You guys need to move around a little bit? Shoot the bunny. All right. Last one. Let's say we have the absolute value of x minus 9 is less than or equal to 12. Okay? And or. And, right? Your variable's on the left, and it's less than. So this is going to be an and problem, which means your graph should look like what? This way, right? Coming together. Okay, so we have to write 2 inequalities. Do you want to try one, Nathan, this time again? What? You did it. We worked through it the last time.
Okay, well, I'll try one more time.
Okay, let's hear it.
X, take away 9.
Mm-hmm.
Other way on the side.
Other way on the sign.
Yes. -12.
-12. Beautiful. Okay, so that's one of them. What's the other one? Ryan, you want to try it? The other one's the easy one. You write it exactly how you see it without the bars, right? So x minus 9 is less than or equal to 12. Okay, so those are your 2 inequalities. Now you solve them. So add 9. You get x is greater than or equal to -12 plus 9 is a -3. Right? This one, add 9. So x is less than or equal to 21. And we said this is an and problem. Remember how you can write your and problems? As one big inequality, right? So your small number, your symbols are always the less than version, and then your big number. So you can write it like this, or you can write it like this. I don't care which way you give me, as long as you tell me it's and, not or. And then when you graph it the right way. So if I'm going to graph this, I have a -3, I have a +21. Open or close dots? Close, because we have the equal to, right? So close dots, and where do I shade? In between them. Okay? It's almost the end of the semester, guys.